Welcome to Head in the Clouds, getting into instrument flying. Today we're going to be covering the six-pack of instruments and the compass. Let's start with the compass because it is one of the oldest and simplest instruments for indicating direction. It basically has a little piece of metal that attracts and holds lines of magnetic flux, and there are two poles on the compass, the North and the South Pole. Now this piece of metal basically floats inside a liquid very similar to kerosene, and it has a graduated scale or compass card wrapped around the float, and it kind of gives us indications of our heading. Now, there are some things we have to keep in mind when we are relying on the compass. It is only accurate during straight and level flight. So if you're in a turn or if you're accelerating or decelerating or climbing, then you really can't trust your compass. So there's also something called deviation, which is error caused by metal inside the aircraft. So far there are turn and dip errors and deviation. And there's also something called variation. And we're going to talk about that in a bit. But let's review. What are the two poles of a compass? North and south, you got it. And when is the compass accurate? During a straight and level unaccelerated flight. Solid. Now let's talk about those errors a bit more. We use two acronyms to remember them. They are UNOS and ANDS. ANDS stands for accelerate north, decelerate south, and UNO stands for undershoot north and overshoot south. Now, what the heck does that mean? Basically, if you are on east or west heading and you accelerate your aircraft, your compass is going to indicate a turn incorrectly. If you accelerate while on an east or west heading, it'll indicate a turn to the north when you are not turning. Let's be clear on that. If you decelerate while on an east or west heading, your compass will indicate a turn to the south. Again, when you are not turning to the south. And then there's UNOS, which stands for undershoot north and overshoot south. So if you are on a northern heading and you make a turn to the right, the compass will actually indicate a turn to the left or lag behind your turn and eventually catch up to you. Now, if you are heading south and you start your turn, then the compass is actually going to overshoot your turn and indicate that your turn is going by faster than you actually are turning. So that's UNOS and ANDS. Now, let's review. What are the two acronyms we use to remember the compass errors? UNOS and ANDS. You got it. Now let's talk about the pitot-static system. The pitot-static system really just works on air pressure. The three instruments that use the pitot-static system are the altimeter, the airspeed indicator, and the vertical speed indicator. Let's review. What are the three instruments that are part of the pitot-static system? The altimeter, the airspeed indicator, and the vertical speed indicator. Let's review the compass errors. What are the two acronyms we use to remember the compass errors? Undershoot north, overshoot south, UNOS, and ANDS, accelerate north, decelerate south. Now, going back to the pitot-static system, we have the airspeed indicator. Now, the airspeed indicator is color-coded for your convenience. The green arc here is the normal operating range. We have the white arc, which is for our flaps, the yellow caution range, and then the red radial line is our never exceed speed. Now, the airspeed indicator basically takes static air from the static port, and then it takes ram air from the pitot tube, and it compares the two. Basically, really, really fast air is compared against static air, and it gives you an indication of how fast you're moving through the fluid of air. Now, looking closer at the airspeed indicator, we have, again, that white arc, which is our flap operating range. Now, the bottom of that white arc, or the low end of it, is our stall speed with full flaps in. The green arc is our normal operating range, and the bottom of that is our normal stall speed. And the top of that is our maximum structural cruising speed. The yellow arc is our structural warning area, and the red radial line is our never exceed speed. Now, there's one V speed that isn't shown on your airspeed indicator, and that's your maneuver speed, or VA. That's just something you have to know from your pilot operating handbook. Now, your altimeter is another instrument that uses static air or air pressure for indicating your situation in the aircraft. It's red like a clock. There are three needles that indicate 100 feet, 1,000 feet, and 10,000 feet. And they are numbered, I guess, 1 through 9 or 1 through 0 or 0 through 9. Yeah. Again, it takes static air and it puts it into this chamber here. Now, we tell the altimeter using a little knob here what sea level pressure is. We change this little aneroid wafer thingy here to indicate or to tell it essentially, hey, sea level pressure feels like this. It takes static air, puts it in here, and it compares the two. And because of the changing pressure, it'll indicate your altitude above sea level. Let's go back and review the compass errors. In your own words, explain what the compass errors are. And if you need to pause this, of course, just pause. Now we've got unos and ands. Ands, again, stands for accelerate north, decelerate south. While on an east or west heading, if you accelerate, your compass will indicate a turn to the north. And if you decelerate, a compass will indicate a turn to the south. And uno stands for undershoot north and overshoot south. If you are in a northern heading and you start a turn, your compass will lag. And then if you start a turn while in a southern heading, your compass will lead ahead of your turn. Accelerate north. Oh, I got it, man. What are the three instruments that operate as part of the pedostatic system? The altimeter, airspeed indicator, and vertical speed indicator. Now let's talk about that VSI, the vertical speed indicator. This tells us the rate of climb or descent. It takes, similar to the altimeter, it has two portions of the unit here. We've got the diaphragm here, and it basically takes in static pressure from that static port, and then there's a calibrated leak on the outside, on the shell, I guess here, and if the two air pressures are the same, the VSI will tell you are at zero foot per minute climb or descent. We are not changing air pressure. But if you climb or descend, there will be a pressure differential in this chamber here. There will be two different air pressures. And as long as those two air pressures are different, it's going to tell you are either climbing or descending. And this is what it looks like. 500 foot per minute rate of climb, 1,000, 1,500, 2,000. Or descent, 500, 1,000, 1,500 foot per minute rate of descent. Again, these are feet per minute here. Let's review the compass. What is deviation? Deviation is error caused by metal inside the aircraft. And what are the two poles of a compass? North and south. And when is a compass accurate? Only during straight and level, unaccelerated level flight. Something we didn't cover, just to want to make sure we do cover it, is variation. If true north, or what we say is north, is at the very top of our planet, unfortunately, magnetic north is not co-located with where we say north is. And so if you ever are looking at a compass, there's going to be a difference between true north and magnetic north, this angular difference here, or our grid magnetic angle. So we have to account for that when we're doing our flight planning, account for that difference between true north and magnetic north. That's called variation, magnetic variation. So there's deviation, which is error caused by metal inside the aircraft, and variation, which is caused by the angular difference between true north and magnetic north. Now let's go back to altitude. There are different types of altitude you'd like to be aware of. They are absolute altitude, which is your altitude above the surface, and we say that's AGL, or above ground level. True altitude, which is distance above sea level, and that's MSL, or mean sea level. Our pressure altitude is if we set our altimeter to 29.92 inches of mercury, standard pressure, then that is whatever we read off the altimeter is our pressure altitude. And then density altitude, this is the pressure altitude corrected for non-standard temperature. But in plain English, density altitude is what the airplane thinks it is flying at. So if it is a really, really hot and humid day, the aircraft's going to think you're at a higher altitude, and it's not going to perform quite as well. So density altitude is the one you really want to watch out for. Then there's indicated altitude. That's what we read off our altimeter. And our standard conditions are 29.92 inches of mercury and 15 degrees Celsius. That is a standard day. Remember that pressure altitude and true altitude are the same when those standard conditions exist. This is a wall of text. Basically, you want to make sure that your altimeter is set correctly. We care because if you are not set correctly, then you can have an incorrect reading on your altimeter. And we use the mnemonic device: from high to low, look out below. If you are going from high temperature to cold temperature air and without resetting your altimeter, you will believe you're at altitude when you are actually descending and you are lower than your actual altitude. So from high temperature to low temperature, from high to low, look out below. And from low to high, clear the sky. From low or standard temperature, without setting your altimeter or resetting your altimeter, and you get into warmer air, you will be higher than actual. From low to high, clear the sky. Your altimeter will tell you, yeah, we're cruising along at the same altitude, but you've actually climbed. And the same thing applies for pressure. If you don't adjust your altimeter and you go from standard or high to low pressure, from high to low, look out below. You will be lower than what your altimeter is telling you. And from low to high, clear the sky. If you are going from low pressure to higher pressure air, then you will be higher than actual. Again, if you don't reset your altimeter or if you don't have it set correctly. Now let's review. What are the types of altitude that we have covered? Absolute altitude is your altitude above the surface. Now, what is it called when we have distance above sea level, or MSL? What is that? That's your true altitude. Now, your pressure altitude is what? That is the height above the standard datum plane of 29.92 inches of mercury. That's if we set our altimeter to the standard setting there. And density altitude? That's pressure altitude corrected for non-standard temperature. That's right. And in our own words, that is what the airplane feels like it's flying at. It's the altitude. This is the key word here in this phrase. It's the altitude at which the airplane believes or feels like it's flying. Let's review the altimeter errors. If you are going from standard temperature air and you get into colder air without resetting your altimeter, where will you actually be? Remember, from high to low, look out below. So we're going to be lower than actual, or we're going to be lower than what our altimeter is telling us. And yeah, so that covers our pedostatic system and our compass. Let's talk about our gyroscopic instruments. The three gyroscopic instruments that we're going to learn about are the attitude indicator, the turn coordinator, and the heading indicator. Now, the attitude indicator is, I like to think of it like flying like a video game. You've got your airplane here in the center, and the ground is brown, the sky is blue, and it also gives us indications of our angle of bank. Now, if you are flying under instruments, you can basically just pretend this is your airplane and fly it around. Nose up, nose down here. This is nose up. Your nose, the little dot here, is above the horizon. Nose down, your dot is below the horizon. If you want to roll into a bank, you roll your wings to the left, and this tells us your angle of bank. You'll roll your wings to the right. There's your angle of bank. If you want to do a climbing right turn or a descending left turn, basically, this is your airplane here. Fly that, and you'll be good to go. Of course, double check with other instruments. Now, our second gyroscopic instrument is our turn coordinator. This tells us information about the quality of our turn, if we are coordinated, and our rate of turn. If we are in a standard rate turn, the aircraft's wings will be pointed at these little notches here. And especially in instrument flying, we want to perform standard rate turns. Remember that a standard rate turn is a 360-degree turn in 2 minutes. And then there's the heading indicator, our third gyroscopic instrument. Now, due to precession, this instrument has to be reset every few minutes, or like 15 minutes, with our compass. And if we ever maneuver too aggressively and it spills, we can recover it by using the cage knob. Now, what are the three gyroscopic instruments? Our attitude indicator, turn coordinator, and heading indicator. And let's review the heading indicator just a little bit more. It indicates our heading. Now, remember that this isn't a compass, it's a gyroscope, so it's going to have its own issues. The compass deals with magnetic flux or magnetic fields, while the heading indicator is all about gyroscopes. It's a high spinning gyroscope. And we did that already. All right, let's talk about glass cockpit stuff. You'll see a lot of aircraft nowadays will have 2, maybe 3 screens. There's the primary flight display, which indicates all our six-pack, like we talked about, and the MFD, which is our multifunction display, which can call up the six-pack, the standard six-pack, as well as moving map and engine data and airport information and a bunch of other stuff. Really cool stuff. Now, just like before, we have our six-pack on our PFD, but now we have a ribbon instead of a round dial for our airspeed indicator, our attitude indicator. By the way, the attitude indicator takes up the entire screen now, so it's really hard to miss. It's hard to not notice that you're in a bank because the whole screen is telling you information about whether or not you are, nose high, nose low, or in a bank. You've got your slip skid indicator here, and then your turn indicator is here. This will tell you if you're in a half rate or a half standard or a standard rate turn. Your altimeter Your vertical speed indicator, now they are ribbons rather than circles, and your horizontal situation indicator, which now combines information about your heading, your navigational aids like your VORs and GPS units. And then, of course, there's the multifunction display. Like we said before, it gives us information about our engine, moving maps, and airport information, and a bunch of other stuff too. Yeah, so that about covers it for what I wanted to cover today. Unfortunately, I am anticipating not being able to make it to our discussion today just because of timing conflict. If you have any questions, feel free to DM me on Discord or ask me questions here in YouTube. And then, yeah, I'll try to get back to you as soon as possible. And if you have questions about, or if you want me to cover specific topics in the future, let me know. We can do those as well. All right. Thanks for hanging out with me, guys. I'll talk to you next time. See ya.